Hello students, in this video we will be discussing the Cbse class 10 NCERT Maths textbook chapter 6 triangles. In that we are going to discuss the theorem 6.1, which is an important theorem. So first we will see the statement of the theorem. The statement says that if a line is drawn parallel to one side of a triangle, so if I'm going to draw a line parallel to one side of a triangle, so let's take this to be a triangle. If I'm going to draw a line parallel, so what will happen? So this line will intersect the other two sides of a triangle. If I'm going to take the triangle to be A, B and C, this line will intersect the other two sides, that is AB and AC, in distinct points. The distinct points are D and E. Okay, so in that case, the other two sides, that is what, the other two sides AB and AC are divided in the same ratio. That means my AD by DB should be equal to AE by EC. So this is what is given in the second part of the statement. That means we need to prove this. So what is given? We are given that DE is parallel to BC. So this is the given data. Okay, and the second part is what we need to prove. Now with no delay we'll get into the proof of the theorem. So in the proof, first we are just explaining that we are given a triangle ABC in which a line parallel to BC is going to intersect AB and AC at D and E respectively. We need to prove this. Okay, now in order to prove this, what we are doing is we are joining B and E and we are joining C and D. Likewise, we are drawing a line DM which is perpendicular to AC, and we are drawing a line EN which is perpendicular to AB. That is, my DM is perpendicular to AC and EN is perpendicular to AB. Okay, now this is the triangle. Now we will have to find out if it is going to intersect the other two sides in the same ratio. Okay, now for this we are considering the area of the triangle. What is the area of the triangle? We all know the area of the triangle formula is nothing but half into base into height. So to consider this, we are going to take three triangles. The first triangle is going to be ADE and the second triangle is going to be BDE. So first we will compare these two, and then this will be our first comparison. Our second comparison will be between the same ADE and between the triangle DE and C. Okay, so this is our thing. So first we will compare these two. We will find out the area of these two triangles, and then for these two triangles we will find out the area, and then we will do a small comparison. Okay, now let's get into this calculation or this proof. I have just redrawn the triangle here. So first, as we said, area of triangle ADE. So I am just taking this side as the base. So half into AD into my height is what? EN. So this is my first comparison. And then area of triangle, I told this triangle BDE, which will be half into base is going to be BD. And for the height, since this triangle is like this, we can't take the height here anywhere because the height should always be a perpendicular line. So even if there is going to be some triangle like this, okay, if there is going to be, I'll just redraw a little bit bigger. Okay, if I'm going to have a triangle like this, even this is a triangle, so my height should be here only. Okay, this will only be taken as the height. So likewise here this En is taken as the height. Okay, likewise we'll do the next thing. The second part, again we are finding for the area of triangle ADE, but this time we are going to take this side as the base. So half into AE into DM. Likewise area of triangle DEC, which will be half into my base is again CE. Now again the height is going to be DM only, because this is only the perpendicular line, DM. Okay, so now let me name all these as 1, 2, 3 and 4. So the next step, I am dividing 1 by 2 and I am dividing 3 by 4. So if I divide 1 divided by 2, sorry, not this 1 divided by 2, it's going to be 1 divided by 2, then you will have area of ADE by BDE. Okay, so then this will also you will divide. So where you will cancel En, half and half will get cancelled. So you will get area of ADE by area of BDE will be equal to AD by BD. Likewise, when you are going to divide this 3 and 4, so you will divide, DM will get cancelled, half will get cancelled. So area of ADE divided by area of DEC will be equal to AE by EC. We know that these triangles, that is my triangle BDE and DEC, are on the same base. What is the base? ED. Okay, and they are between the same parallels, because we are already given that DE and BC are parallel. Okay, so these two data we are given. So from this we can say that area of these two triangles are equal. What is equal? Area of triangle DEC and area of triangle BDE are equal. BDE is equal to area of triangle DEC. So when these two are also equal, we can equate the right hand sides. Okay, so thus we can equate the right hand side. So my AD by BD, which is equal to AE by EC. So that is what BD can also be written as DB. So nothing wrong with that. AD by DB will be equal to AE by EC, which is what we had to prove. Got it? So from this we are able to prove the theorem 6.1. So this theorem is also called the basic proportionality theorem or the Thales theorem. So you need to remember these names also. Basic proportionality theorem or the Thales theorem. So once again we'll revise the proof. So in this proof we are considering the triangles in this fashion. You should remember you remember these two, then you can remember the entire case. Okay. So this is the first case, this is the second case. First case ADE, that is this triangle, and then this triangle you are taking. Okay. Next one, you are going to consider this entire triangle and this side. So you will get two values, so that you will have to divide among themselves, and then you will say that both these triangles are in the same base DE. So we can say that both are going to be be similar. The area will be the same. So when the area is the same, we can equate the right hand sides, that is AD by PD equal to AE by EC, and thus we have proved this theorem. Hope you have understood this theorem, children. Please go through this video once again. If you have any doubts, we'll look into the other theorems in this chapter in the upcoming videos. If you have any doubts, please do comment in the video. Okay, so thank you, children. See you again in another video.